Hi everyone. So today we're gonna look at Leetcode daily challenge problem number 2421, number of good paths. So it's a Leetcode hard problem, and it by no means is anything less of an hard because they have this few conditions which we'll have to track. They have the structure which will the tree which we have to traverse, and we'll have to do that in such a way that it is optimized as well. So the given problem is there is a tree consisting of n nodes numbered from 0 to n minus 1 and exactly n minus 1 edges. So they have given that with n minus 1 edges, basically we can say that there will be no cycles in it. Okay. Next part is you are given a zero index array values of length n, where values of I denotes the value of ith node. Okay. You are also given 2D integer array edges, where edges of I represents edges between two nodes. That is fine. A good now we have a definition for the good path. What exactly is a good path? A good path is a simple path that satisfies the following condition. Starting and ending node should be of the same value. All nodes between the starting node and ending node have value less than or equal to starting node. Okay, so these two are the conditions which represents a good path. And at the end we have to return the number of distinct paths. Also, they have given that note that a path its reverse are counted as the same path. For example, 0, 1 is exactly same as 1, 0. Okay. Now, in this example, we can simply say that these numbers in the nodes are the indexes of the nodes, and the numbers mentioned with the blue color are the actual value of the nodes. Okay. So a good path is when the starting node and the ending node have the same values. Okay, and all the nodes between the path must be less than or equal to the value of starting node. Okay, so let's say in this example we have 3 3, right? So a potential good path could be this, right? So if you check, yes, we can go to this node because the value was less. Then we can move to the second node because the value of that node is also less, and finally we'll reach to the end node. Okay, but we cannot do that with this particular flow 0 2 and 3 because okay, first and like start and end node is same with same value, I mean to say, but the next node, like you we don't have any next node which we can go to because the value of the nodes are greater, right? So these two are the condition which represents a good path. And to to solve this, I'm going to use union find method. Okay, so it's basically a discrete set joint problem, and I'll be using union find method uh, to tackle the problem. So let's move to the solution first. I have already coded the basic function for the union find, like which we will use, and you can check out my last video, which I'll link in the I button and in the description as well, to get a better idea of what exactly union find is. Next, we will start working on the solution. And it's going to be a little tricky. Like the solution is going to be a little tricky, and I'll explain you on the go, like what exactly we are doing. Okay. First, I want to check the how many nodes we have. Okay. So we got that. Next, I want to prepare a agency matrix. Okay, which will store the path between two nodes if there was an edge between the two nodes or not. Okay, so first in range n. Okay, this is done. Next, I'll simply just iterate through the edges array which we have received, and I'll populate my agency matrix. Okay, so of edge 0, all the edges are undirected, so we'll have to add the edge between the both. For example, we will have an edge from A to B, and we'll also have to add that from B to A as well. Okay, so this is done. Let's just copy paste same line. Okay, okay, so this is done. Next thing which I want to do is create values to node, like a map which will yeah, which will basically keep a track of all the neighboring nodes or all the attached nodes from a particular node. Okay, so by attached node, I mean the nodes which are sharing the same values. Okay, so let's say for I comma, I'm using enumerate as I do want the index of those values as well. Okay, next is values to nodes dot. Let's use set default so that we don't get a key error in any case, and initialize with an empty array and use. Okay, so basically all the nodes with the same exact values. For example, in the in the diagram which we just saw, we had 3 at two locations, at index 1 and at index 4. So this dictionary will keep the record of that. Okay, so now we have all the edges mapped and all the nodes with same values. Okay, now I want to perform my union find on it. Okay, so to do that, let me create an object first by disjoint set union and union find of index, let's say. Okay, this is done. I passed on the size of it so that everything can get initiated. So this part is done. Next, I'll initialize the value which I'm going to return at the end with 0. So with 0. Okay, so we are done till this point. Next thing which we want to do is we want to traverse the values to node hash which we have prepared. Okay, so to do that, for value is the key which represent the actual value of a node, and node is the index value. I'm talking about the with the reference which we discussed while talking about the diagram. Okay, now values to node dot items. Okay, so this sorted is gonna pick the values in a sorted key manner. Okay, so we are done till this point. Now, for there could be multiple nodes for a value. So done. Now I want to check the relation with each adjacent node. So we are going to use this particular matrix which we prepared, right? For neighbor in adjacent node. Okay, we are done this point till this point. Uh, we know that good path had a condition where all the values in a path should be less than or equal to the starting value, yeah, starting node. So before performing a DSU, union operation on that, I can check that so that we'll have limited operations to perform, limited nodes to perform operations on. So I want to check between node and the neighbor. If node's value is greater than or equal to the neighbor's value, then only I want to perform a union set operation between node and neighbor. We are done till this point. Now I just simply want to do the grouping of each node. For example, like if a node can be seen in a particular in a given path or not. So to do that, I'm going to use this new hash map. Okay, and I'll be checking the connected components basically. Okay, and I'll be using that to count the number of good paths. So to do that, what we can do is let's traverse through this node. Yeah, for node in nodes. Let's like now group. I'm gonna find parent of the node and want to set the the value issue.find with an increment of one. Okay, so we are done this point. Like we have grouped all the connected components. Now it's just about finding out the size. So to do that, I'll be traversing the groups which we have prepared. And sorry, I forgot semicolon over there. And good paths will be equal to or yeah. So we are done with the solution. We'll just simply return the variable in which we are storing our solutions, and we will be good to work. Oh, sorry. Let's check the test cases. Yeah, so the solution got accepted successfully. Sorry, the test cases got passed. Let's submit for further evaluation. Yeah, so the solution got accepted, and we performed decent. We outperformed 81% of the submitted solutions. So yeah, thanks again guys for watching the video and stay tuned for the upcoming ones. And don't forget to subscribe to the channel. Bye.